So we'll see a summary of the OT hacking. So the first is Purdue model. The Purdue model is derived from Purdue Enterprise Reference Architecture PERA model, which is widely used to describe internal connections and dependencies of important components in the ICS networks. It consists of three zones: manufacturing zone, enterprise zone, separated by a demilitarized zone. The three zones are further divided into several operational levels. Other system like ICS or RTU is ITS or TCS, HMI is basic process control system. BPCS, a basic process control system, is responsible for performing process control and monitoring for industrial infrastructure. Safety instrumented systems, SIS, a safety instrumented systems. SIS is an automated control system designed to safeguard the manufacturing environment in case of any hazardous incident in industry. So, an example may be a fire control system. A Modbus. Modbus is a serial communication protocol that is used with PLCs and enables communication between many devices connected to the same network. Profinet. Profinet is a communication protocol used to exchange data between controllers like PLCs and devices like RFID readers. Six low six low PAN. It's IPv6 over lower power PAN personal area networks. 6 low PAN is an internet protocol used for communication between smaller and low power devices with limited processing capacity. It is mainly used for home and building automation. 6 low PAN. So WiMAX, worldwide web interoperability for microwave access. WiMAX is based on the standard IEEE 802.16 and is envisioned for wireless metropolitan area networks. WiMAX operates at frequencies between 2.5 GHz to 5.8 GHz with a transfer rate of 40 Mbps. Exploiting RF remote controllers. OT networks use RF technology to control various industrial operations remotely. RF communication protocol lack inbuilt security for remote communication. Vulnerabilities in these protocols can be exploited by the attackers to perform various attacks on industrial machines that lead to production sabotage, system control, and unauthorized access. HMI based attacks. Attackers often try to compromise an HMI system as it is the core hub that controls critical infrastructure. Side channel attacks, timing analysis, and power analysis. Hacking programmable logic controller. PLCs are susceptible to cyber attacks as they are used for controlling the physical process of critical infrastructures. Attackers identify PLCs exposed to the internet using online tools such as Shodan. Attackers can tamper with the integrity and availability of PLC systems by exploiting pin control operations. The attackers can also launch attacks like payload sabotage and PLC rootkits. Hacking industrial systems through RF remote controllers. Um, there are different methods in this. The first method is replay attack. Attackers record the commands transmitted by an operator and replay them to the target systems to gain basic control over the system. And second, command injection. Attackers alter RF packets or inject their own packets employing reverse engineering techniques to gain complete access over the target machine. Repairing with malicious RF controller. Attackers hijack the original remote controller and pair it with the machine using a malicious RF controller, which they disguise as a legitimate one. Malicious reprogramming attack. Attackers inject malware into the firmware of the remote controllers to maintain a persistent and completely remote access to the system. Abusing e-stop is the next attack. The attackers can send multiple e-stop, that is emergency stop. So attackers can send multiple e-stop commands to the target device to cause DOS. OT malware, Mega Cortex. Megacortex is a novel ransomware that targets OT networks, corporate networks, and industrial sectors. It is installed on compromised systems using Trojan downloaders such as QAK bot, Aka QBot, Emotet, and REIT spoof. Additional examples of fileless malware: Locker Gaga, Locker Gaga, Locker Goga, Locker Goga, Sam, OT malware analysis, Locker Goga ransomware. Locker Goga ransomware has attacked many industrial organizations such as building and construction, financial services, metals, chemicals, data storage, and warehousing by compromising their critical operations. To execute Locker Goga ransomware, attackers need administrative privileges, and therefore, before running the ransomware, attackers must gain access to the target system and elevate their privileges. So there are different stages, just like the DIN attack. Was that DIN? I think so. So stage one, initial execution. Locker Goga injects a copy of itself in temp tgu tgytutrc number.exe and executes with a dash m parameter. Dash m represents master. If dash l parameter is enabled, details of the malware are returned to C log. Step 2, running master process. Executes master process to search and identify files to corrupt, uh, lock out admin accounts, and disable network interfaces. It uses the slave process for encrypting the files. Running slave process spawns slave processes for encrypting the files. The slave process expects input from the master process to the file paths for encryption. Step 4, ransom note. The last stage involves the dropping of the ransom note readme now.txt into the desktop of the current user. This note contains instructions related to the ransom payment, such as email addresses and payment instructions. The next is identifying ICS SCADA systems using Shodan. Attackers can gather information on a target device using the following filters. Search for Modbus enabled ICS slash SCADA systems system colon port colon 502. So systems port 502. So retrieves all ICS SCADA systems with Modbus port 502 enabled. So this implies that Modbus runs on port 502 and ICS and SCADA will use Modbus. Search for SCADA systems using PLC name. So PLC name colon Schneider Electric. Search for SCADA systems using geolocation SCADA country colon US. Gathering default passwords using Critifence. Critifence is an online database that stores default passwords of critical infrastructure, SCADA, ICS, and the IIoT. Attackers can also use tools such as SCADA Pass. Scanning ICS SCADA using Nmap. Please pause and have a look at this. So here the Nmap, the switches given are -PN, that is to indicate no ping, and then -ST to indicate TCP ping, --scan -delay 1 second, and --max -parallelism L and -P, and it lists there is a long list of port numbers and then the target IP. Attackers use this nmap command to perform initial reconnaissance to identify active ICS SCADA protocols. The port numbers listed in the command are well-known port numbers used for ICS SCADA protocols. Identify HMI systems. Nmap-pn-st-p 46824 target IP. So this 46824 is an example for a HMI software called Cialco's Systemi Winlog, scanning Siemens System Sematic S7 PLCs. The port number is 102. Scanning Modbus, port number is 502. Enumerating slave controllers using SCADA shutdown tool. So, shutdown tool is used to enumerate slave controllers using SCADA. Vulnerability scanning using Nessus. Vulnerability scanning using Skybox vulnerability control. Sniffing using network miner. Discovering ICS SCADA network topology using Grass Marlin. GRASSMARLIN. Hacking Modbus slaves using Metasploit. It's an auxiliary module. It is auxiliary slash scanner slash SCADA slash Modbus underscore find unit ID. Hack PLC using Modbus dash CLI. It uses simple commands like Modbus read and Modbus write. Gaining remote access using DNP3. Information gathering tools. Search Digity. Search Digity is an information gathering tool that includes Shodan Digity, a scanning interface to the popular Shodan hacking search engine. It comes equipped with a convenient list of 167 search queries. Search Digity for information gathering. Sniffing tool, Smart RF packet sniffer. Vulnerability scanning tool, CyberX. OT hacking tool, ICS exploitation framework, ISF. International OT security organizations. Some of the security organizations related to OT are listed. Operational Technology Cyber Security Alliance, OTCSA. Operation Technology Information Sharing and Analysis Center, OT ISAC. Operational Technology Security Association, IOTSA. Firewalls for OT, SCADA wall, Waterfall, and Palo Alto NGFW. Palo Alto. Palo Alto NGFW. These are the firewalls. SCADA wall, Waterfall, and Palo Alto NGFW. Security professionals can use tools such as SCADA Fence, CyberLens, Guardian, and Dragos for asset inventory and device authorization. Security professionals can use tools such as Clarity and OT Threat Feed for OT network monitoring and anomaly detection. Security professionals can use tools such as Threat Defend, Conpot, and Gaspot to protect the network. So, Threat Defend, Conpot, Gaspot to protect the network. Flowman empowers manufacturers and utility companies to ensure the reliability of their industrial networks confidentiality to avoid downtime and disruption of service continuity. This can be achieved by continuous monitoring and anomaly detection so that malfunctioning devices or security incidents such as cyber espionage, 0 days, or malware can be reported and remedied as quickly as possible. Flowman.